Good morning, welcome to the next session. Now today I am going to talk about managing data science project, and I'll try to understand the project failures, why data science project fail. We have already seen about the innovation technology, and we have also seen about the disruptive technology. So we develop a recipe that can help to find out the ideas of a data science project that need the market demand. The problem is, today we are going to cover non-technical side of the data science project that is stand out from the general software development project. So a software development project and a data science project follow a different style of working, and I am going to talk about why data science projects are likely to fail more often than the traditional software development project. We will look at common reasons for their failure and develop an approach that will lower the risk of my data science project failure and dive into the art of a project estimation and how do you estimate the cost of a project. So the topics I am going to cover in this series is understanding project failure, data science project life cycle, choosing a project management methodology and choosing a methodology that suits your project, and finally estimation of the data science project and discovering the goal of a estimation process. So let us see why very important concept, that why data science project fail, what is the failure rate and why they are so often failing, and what is the recipe to address the failure issue so that they will be successfully deployed for months together on a website or any other data science project. So every DS project ends up building a software system that generate schedule reports or operate on the online. So we have already seen about the online testing and offline testing. When I go for a online, the word software engineering already provide us with a multitude of software project methodologies. So why do we need to reinvent the whole approach? Very simple idea and very simple questions too. The answer to this question is data science project require much more experimentation, whether traditional software development 1 or 2 iteration or 10 iteration it is over and you have fully tested the system. However, this is not the case with the data science project. So I do require a lot of more number of experimentation and have to tolerate far more failure than the software engineering project. So this is the underlying answer for it. Now let us look at the common pitfall. Number 1, in data science project, I am depending upon the underlying data. Number 1 answer. A robust customer relationship CRM that organizes the sales process will work in many organizations independent of their business. So this is another real world example where I have a sales department and the department is working throughout the country or throughout the subcontinent. A system that predicts the outcome of a sales process may work well in one organization, but will require a partial rewrite for another organization and may not work in the other altogether organization totally. So what is the reason? The reason for this is that machine learning algorithm depend upon the very good principle called as data. So I am more or less depend upon the data, and every organization will have its own set of data model to customers and its whole sales process. So different sales processes are there, different data sets are there, and the chances of failure are because of the customer relationship management. Your data and your sales process or management relationship is not coherent, and that is one of the reasons for a data science project failure. Second is so the second reason is changing requirement. While software development projects often suffer from the changing requirement, the changes most likely to flow from the customer to the implementation in the software project cycle. So new insight and research result from the implementation team and can create a feedback. So in our data science, changes is the must. You keep changing the data and your understanding of the model gets better and better. So project stakeholder can generate new requirement and change a course of action for the project based on the new information that is discovered by the data scientist. So this is another reason, because the requirements are keep on changing, and the changing requirement leads to me a problem of a sometime failure too. Changing data, as we have seen, data keeps on changing, so data processing technique, model learning, everything will also keep on changing. Last but not least, experimentation and research. Data science project involve completely many number of experiments. This is the underlying principle of a data science project. Typically the number of ranges from 100 to 1000 number of iterations. And the software engineering project limit research only by designing a system architecture and evolving in a controlled manner. So unlike our data science project, traditional software engineering is done in a controlled manner. However, in data science project, the next experiment may turn out the project in a totally new direction, and you never know what is going to happen next. So this is also one of the most important reason for a data science project failure. So how do I deal with? So understanding management approaches. Number one is traditional management approach of software engineering will not work here. So what is that? The key problem that most often software project management should solve is the issue of the what we call as a changing requirement. So the underlying principle is keep the changing requirement minimum. And if the requirement are kept minimum, naturally the failure rate will become less and less. Agile methodology focus on planning and execution fast iteration. So we know about the software engineering principle, agile methodology, which goes on a faster and more of a quick execution iteration. Each iteration aims to deliver functionality to the client as fast as possible. So this is the underlying principle. Try to develop the software more faster than traditional documentation. All those things we need not to worry about in the agile methodology. External feedback is the primary source of a change in the project. So in DS, changes come from every direction. There is only one way. Now in data science project, the changes are going to be incorporated from all the direction. They spread internally from the project team and externally from the customer business. So the changes are going to be from the internal team members or the customer requirement changes. So what we have to do? Metric should always confirm the progress. So I have to have a good measure of the metric performance, and it keeps a confirmation of my changing of the progress. Getting one step closer to your goal may take 10 or hundreds of the failure experiment, which makes the fast iteration is a must. So failure are there, you redeploy the model and again try to do it, and this is how it will go. And so typical iteration length of the agile project can stretch from 2 weeks to maybe 1 month time, and that is one of the reasons that data science project take a lot of time. Then if you develop a system that machine learning under hood, it is necessary to take care of the following. Number one, requirement for validation and alignment. You need to detect and manage the requirement changes from a external, that is your customer, to the internal, that is your research team. Very important is data governance. So your project need to have a data governance standard, which should be rigorously applied to each piece of the code that works on the data. So if you follow this principle, the failure rate will be less and less. Research project, each data science project need to be researched extensively. So it's unlike our traditional software engineering. I need first principle, research planning. Project team should plan and prioritize their research. Next, experiment methodology. Each experiment should conform to the set of standard that shows about the tracking, documentation, and a very important concept called as reproducibility. The same software should be working today, tomorrow, and day after. It should be able to reproduce the same answer tomorrow. Last but not the least, fail fast and recover early. So your project, let it fail, but it should be able to recover very quickly. So experiments often fail. Your management approach should make the experiment fast, so that your team can iterate and learn as quickly as possible. So this is the underlying principle of my taking care of the subject failure. Now here I am showing you a life cycle of the data. So data science life cycle is shown. You can see here the data is in the middle, and I have a business understanding, data preparation, modeling, evaluation, and deployment. So there are 6 blocks which have to go in a cyclic fashion. So let us see one each of the block. So each data science project have several distinct states. We can structure project in a different domain and different technologies stage for different. So a insurance company will have a different set of data, a university will have a different set of data, and so on and so forth. So every organization will have a different set of the data, but this principle are applied to everywhere. So number one, business understanding. So here I am. So I am trying to learn about the business. So during this stage, we apply the domain expertise and research for the business of the project. Okay, when we can define the business requirement and confirm the implementation point. So here is the people who are doing the business and they confirm to the customer need, they go with the business requirement and things like that. And the next one is the data understanding. So I need to understand the data. So when I understand the data, I can do a exploratory data analysis, which we already know from the our statistical tools of the machine learning algorithm. So we can do a exploratory analysis on the data itself. So I can understand my data much better, like mean, median, variance, covariance, all those EDA algorithm or EDA matrix, we can use it here. Okay, then we have data source dictionary. This dictionary, okay, this document briefly describes all kind of source of the data that are relevant to our project. So like our what we have in our DBMS, we also have a repository called as data source dictionary, and then finally I have a EDA report that shows the conclusion of my data analysis. So if we follow this principle, the things will become easier. I need to prepare the data. So at this stage, we start working with the data, and data preparation involves taking raw data and change into a usual format. So that is already we know from data warehousing and mining, we require a pre-processing of the data, and it can be the data can be unstructured form, it has to be converted into, or normalization. All those preparation need to be done under the data preparation. Then optimize the data. So when I have done the data preparation, I need to optimize the data. Which is the data more relevant to me? So optimization technique we can use. Okay, normalization technique also we use, and we can develop the data pre-processing in a better way. So to make this process less error prone, it is easier to monitor. You should care about the data provenance and versioning. It's okay. So data keep on changing as we have seen, and we have to worry about the version. Okay, previously what was the data and today what is the data. So that is called as a version change, and take care to save the data file regardless of their type of the intermediate law. Okay, raw. Log the input and output every data transformation job done in the code. So if I keep a log, I'll know what was the mistake I committed last time. So this will save my data for project failure. So doing this increase will increase the technical depth, and the code will work for a while and it will fail only without notice. So over a time you will also add additional features of the code and the life become very easy. Then second topic about this is modeling. So this topic was what we covered in data science, and this section will be report about this. So first determine the task that is supervised or unsupervised. So we do the modeling and we go with the supervised algorithm, we go with the unsupervised algorithm, then we process the algorithm. This already we have seen in the detail previously too, and we go for a evaluation. So whenever data set is there, we have to go and deploy the model and set up our evaluation criteria. We take the matrix, we take the log, we take the artifact and effect on the reproducibility of the data set. So this is all evaluation process, and then finally we go with the deployment. So whenever a data science project is there, we have to deploy. But before we deploy the software project, we have to go with the software engineering principle or cloud computing principle called as SLA, service level agreement. So at a deployment stage, we publish the best model for our end user and examine all the detail. So complexity are overlooked and production code has to be done, and a service level agreement of the model has to be made. Okay, so which are the services which are going to be provided by your model. So we can say we can separate this requirement in two categories. One is a functional one and another is a non-functional one, same as our software engineering. Functional requirement define your service features, while non-functional define your service level agreements. Some example of functional requirement are like request response format, capability model versioning, and user interface for tracking the deployment. And for the non-functional requirement, we have a what is the throughput, what is the availability schedule available, and security communication and elasticity available for my data set. So with this, end here and we go for a deployment with the service level agreement. So, if we follow this certain principles, my rate of the failure will be diminishing. Failure will always happen, but if we follow certain standard practices, the failure rate can be drastically reduced. Thank you.